Alright, what's up guys? So today we are starting Unit 9, which has to do with the measurement of three-dimensional shapes. So last unit we did everything with two-dimensional shapes, so now we're going to go into everything with three-dimensional shapes. So the first thing we're going to start out with is 9.1, which is going to be about surface area, so everything on the outside of the 3D shape. So let's go ahead and move on into our notes here. So the first thing we're going to look at is the two formulas you're going to be looking at. So specifically, first thing we're going to learn is exactly what is lateral area and what is surface area and how do we find both. So let's just go to the vocabulary and we'll talk more about the formulas here in a second. So the first one, a blank, is a polyhedron with exactly two congruent parallel faces, and this is going to be known as a prism. So a prism has exactly two congruent parallel faces. The blank of a polyhedron are the parallel faces. So the parallel faces are going to be known as your bases. Blank are the faces on a prism that are not bases. So these are going to be known as lateral faces. So anything that is not a base is going to be known as a lateral face. Everything in between the bases. And blank is a perpendicular segment that joins the bases. This is going to be known as the altitude. So the altitude are the edges that are in between the two bases. And the blank is the length of the altitude, which is known as the height. So height and altitude are technically the same exact thing. So the blank is the sum of the areas of the lateral faces. So this is going to be known as lateral surface area. So all the area not including the bases. And then everything that is the sum of the lateral faces and the sum of the two bases is going to be known as surface area. So if I'm talking about surface area, I'm talking about everything on the shape, everything around it. Okay? So now we can actually look into lateral area and what I mean here. So let's go and look at our figures over here. So right now this top figure, if you look, the top and bottom shape, if you look here, are going to be pentagons. So this is going to be known as a pentagonal prism. And what I want y'all to know is whenever you're looking at anything that's a prism, whatever the two lateral faces are, that's going to be the name of it. So if I say rectangular prism, the bases are rectangles. If I say triangular prism, the bases are triangles. Okay? And then down here on the bottom, if you look, the two bases are triangles, so this is going to be known as a triangular prism. Triangular prism. So now let's look at what these are pointing at. So looking at the pentagonal prism, if you look, these two arrows here are pointing at the two bases. So these are going to be your bases. Okay? On the next one here, these arrows right here are pointing at the segments in between the two bases. So this is going to be known as your altitude, or you can call it your height, whatever you want to call it, altitude or height. And then lastly, these arrows right here are pointing at the lateral faces. So everything in between the lateral faces. So now that we know some vocabulary here, now we can look at our formulas. So first talking about lateral area. So to find lateral area on prisms, if you look here, the capital P stands for the perimeter of the base. So I want you to actually write this in your notes. It's going to be the perimeter of the base. So I'm actually going to look at the base and I'm going to take the perimeter. And then obviously H here is going to stand for height or the altitude. So literally all I have to do is find the perimeter of the base and then multiply it by the height, and that's going to give me my lateral area. So surface area, if we look here, surface area is equal to pH, which is the same thing as lateral area. So whatever you get for lateral area, you can plug it right here into these two segments here. And then we're going to add 2 times capital B. And what I want y'all to know is capital B is going to be equal to the area of the base. So anytime you see a capital B, it always stands for the area of the base. Okay? And then lastly, we're looking at the lateral area and surface area of a cylinder. So the difference between a prism and a cylinder is a cylinder has a circle. So we have to end up bringing the pi stuff in. So if we look right here, 2 pi r also represents circumference. So we're technically multiplying all the stuff that's going to be the perimeter, because in a circle, the perimeter is the circumference, and all I have to do is multiply it by the height. Or if I'm given the diameter, I do pi times diameter times height. Then for the surface area, I do lateral area again, which is 2 pi rh, or pi times diameter times height. Then I have to do 2 times the area of a circle, because I have 2 bases that are going to be your circles. So here in a little bit, whenever I look at the examples, I'm going to put both of these into play very easily. So earlier I talked about specific pieces of prisms. Now we're going to talk about different types of prisms and also some definitions about cylinders. So on this definition right here, a blank is a prism whose lateral faces are rectangular regions and the lateral edge is the altitude. So this is going to be known as a right prism. So basically, if the edges are going to be the altitude, that would be known as a right prism. So over here, these are examples of right prisms, because if you look, this guy right here is going to make a 90-degree angle, and that's going to make it into the height. So that's what makes it a right prism. Okay? And so over here, a blank is a prism whose lateral faces are not perpendicular to the base, is known as an oblique prism. So over here, this is known as an oblique prism. Okay? And so now looking at a cylinder, a blank is a 3D figure with 2 congruent parallel circular bases, is going to be known as a cylinder. The blank is the area of the entire curved surface. So the curved surface is in between the 2 bases. So this is going to be known as lateral surface area. And then the lateral surface area plus the 2 bases is also going to be known as surface area. So whatever you're finding surface area of a cylinder, they're kind of the same thing as a prism. Okay? And now a blank is a cylinder where the segment joining the centers of the bases of the altitude, or also known as perpendicular, is going to be known as a right cylinder. And then obviously when it's not right is going to be known as an oblique cylinder. And now just to point out some specific things about these. So obviously down here in the bottom left hand corner, this is going to be known as an oblique cylinder because it's not 90 degrees with the base. Up here, these arrows right here are pointing at obviously my 2 bases. And then down here, these are going to be known as right cylinders. So what we're going to do is we're going to take these definitions and take these formulas that I just used, and we're going to put it into some examples.
Alright, what's up guys? So this is example number 1. So right now we're looking at surface area, and inside the notes you learn 2 different types. You learn something known as lateral area and surface area. So what we're going to do on example number 1 is we're going to find the lateral area first, then the surface area of a triangular prism. So the one thing you guys need to remember is that whenever you say triangular prism, that tells you what the bases are. So if my bases are triangles, that means these 2 triangles are my bases. So I need to make sure when I'm finding lateral area, that's going to be everything in between those 2. So inside your notes you learn lateral area is known as capital PH. Capital P stands for the perimeter of the base. Okay? Then the height obviously is going to be the height in between the 2 bases. So right here to find lateral area, I'm going to do the perimeter of the base. So 6, 8, and 10. I'm going to add all those together. So 6 plus 8 plus 10. Then I'm going to multiply it times the height. Remember, the height or the altitude is going to be in between the 2 bases. So that's 5. So I'm going to multiply it times 5. So if I did 6 plus 8 plus 10 plus 5, that is going to come out to a grand total of 120 centimeters squared. So that would be your lateral area. So now, to find surface area is going to be lateral area plus the two bases. So I'm going to do lateral area plus 2 times the area of the base, and that's what capital B stands for. So I already know my lateral area, so I'm going to plug that in for LA. Then I'm going to add 2 times the area of the base. Well, you can ask yourself, what's the shape of the base? That's going to be a triangle. So the area of the base is 1/2 base times height. So I'm going to do 2 times 1/2 base times height. Remember, lowercase b stands for the base, h stands for the height, so 8 times 6. So I'm going to do 120 plus 2 times 1/2 times 8 times 6. And whenever I plug all that in the calculator and I multiply it out, you should end up with 168 centimeters squared. So remember, ladies and gentlemen, lateral surface area is everything in between the two bases. Surface area is everything put together. Alright, ladies and gentlemen, so the next one we're going to look at is your second example, which is going to be a rectangular prism now. So remember, again, I want to say it again, whenever they give you the shape, they're going to tell you what the base is by the name. So if I say rectangular prism, that means the two bases are going to be rectangles. So if we look here, the bottom is shaded, so that's base 1, so the base 2 is going to be on top. So we need to find lateral area first, then we're going to find surface area. So again, capital P stands for the perimeter of the base, the H stands for the height of the shape. So what I'm going to do, to find lateral area, I'm going to do the perimeter of the base, and I know the base is going to be a rectangle. So this is 6, a 3, a 6, and a 3. So I'm going to do 6 plus 6 plus 3 plus 3. So that's the perimeter of the base. Then I'm going to multiply that by the height, which is 4. So whenever I put all that in the calculator and multiply it out, the lateral area of this guy is going to be 72 centimeters squared. Okay? So now to find the surface area, I'm going to take the lateral area, which I just found, and I'm going to add 2 times the area of the base. So surface area is going to equal 72 plus, and right here I have a rectangle, so it's just going to be length times width. So I'm going to do 2 times 6 times 3. Whenever I put all that in the calculator, the total surface area is going to be 108 centimeters squared. So literally I'm just taking the stuff and plugging it into the formula and making it work out for both of my total and lateral surface areas. Next, I'm looking at finding the lateral area and surface area of a cube. So again, I know the bases of a cube, if I look on the top and bottom, are going to be squares. So that means I'm going to take lateral area, which is the perimeter times the height. Then I'm going to find the surface area, which is going to be lateral area plus 2 times the area of the base. So let's go and find both of these. So first let's find the lateral area. So capital P here stands for the perimeter of the base. So this is my base. So I know this is 3, this is 3, this is going to be 3, and this is going to be 3. So I'm going to do 3 plus 3 plus 3, or 3 times 4, it doesn't matter. So 3 plus 3 plus 3 plus 3, okay? Then I'm going to multiply it times the height, which we look here, this is going to be my height, so I'm going to multiply it times the height. So whenever I multiply all that out, I should end up getting 36 inches squared, because this is going to be measured in inches, okay? Next, we're going to find surface area. So again, surface area is lateral area plus 2 times the area of the base. So again, my lateral area is 36. And I'm going to add 2 times the area of the base, which 3 times 3 is going to be my length times width. So 3 times 3. So whenever I put all that in, or I multiply it out and solve it, I should get 54 inches squared. And literally, guys, this is how easy plugging all this into the formula. As long as you remember these two formulas, surface area is going to be a piece of cake for you guys. Alright guys, so the next example that we have, which is going to be example D, we're going to first look at a cylinder. So we're going to be looking at the lateral area of a cylinder and the surface area of a cylinder. So first, we've got to understand lateral area is everything in between this guy. So like earlier, we did perimeter times height. So the perimeter of a circle is known as circumference. So if you look right here, 2 pi r, this is going to be my circumference, or also known as my perimeter. Then I'm going to multiply it times the height. So we're technically doing the same thing we did with the prism, but it changes up because we have a circle now. Okay? So now for surface area, we're going to take this guy, which is going to be my lateral area. Then we got to multiply it by the two bases. So remember, find the area of the base, it's pi r squared, so we're going to multiply that times 2. So literally all we have to plug in is the radius and height on both of these and we get our answers. So lateral area is going to be 2 times pi r times h. My radius is 4, my height is 10, so I'm just going to plug those in. 2 pi times 4 times 10. I multiply all this out, that's going to give you 251.33 inches squared, which is going to be rounded. I rounded the 3 right there. Okay. Now for surface area, we're going to take all that, so just what I plugged in here, 2 pi r h, we're going to take that right here, lateral area, so 4 times 10, and then all I'm going to do is plug in the radius right here, which was 4, so 2 pi times 4 squared. So literally all we're doing was taking the radius and plugging it in. So after I multiply and add all that out, the total surface area is going to be 351.86 inches squared. And remember, area is always measured in squared inches. Alright, and on my last example, we have another cylinder, but on this guy, it says in the directions to find my answer in terms of pi. So remember back whenever we were doing stuff last semester, when it asked for in terms of pi, that means multiply everything, but forget about the pi and tack it on at the end. So I'm going to show you guys how this works. So again, we're going to find lateral area, which all we have to plug in is the radius and the height. So right now I have the diameter of 10, so I have to cut that in half, and that's going to plug in for r, and then I'm going to plug in the height. So for lateral area, I'm going to do 2 times pi times the radius, which is 5, times 15. So remember, ladies and gentlemen, when I say in terms of pi, I'm going to multiply everything except the pi, and then tack it on at the end. So if I did 2 times 5 times 15, that is going to give me 150 centimeters, which, again, I have to bring back the pi, so that's going to be 150 pi centimeters squared. So that's going to be in terms of pi, ladies and gentlemen. So now I'm going to do the same exact thing with surface area. I'm going to plug everything in, multiply everything except the pi, and then tack the pi in on at the end. Okay? So here we go. So surface area is going to be 2 pi, my radius again is 5, my height is 15, plus 2 pi, my radius is 5, squared. Again, I'm going to type in everything except the pi, and whenever I type all that in, you should end up getting 200, tack on the pi, centimeters squared. So that's going to be your answer in terms of pi on both of those. So ladies and gentlemen, this is how you find lateral area and surface area in simple